So we have the point. So if I were to take this as 1, 2, 3, 4, we are having -1 down. Okay, this point is -1, this point is 4, so this is going to be my point P, and if this is taken as 1, 2, and all the way from 2 we have a hit, so this point is Q, and 3, 4, 5, 6, 7 is corresponding to 3, so there is, this is R, and you have a link between and then we are asked to draw, okay, this is 4, you are asked to draw OS, so this is 5, 6 and 7, 0.7, 7 and 4, 1, 2, 3, 4, this point is 4, so you have S is some area. Okay, so from the origin we connect the point. Okay, okay, so this is my OS. Now if we complete it, this is actually producing a parallelogram. Okay, so now we will have to show that QP, opposite side, QP is equal to RS. Okay, if we are able to show QP and RS are one and the same, then solution is complete. So let me find a QP. So to find a QP, what we have to do is subtract Q from P. So what is P? P is 4, -1, 4, -1, and Q is 0, 2. So 0 and 2. So this is going to give me 4 and -3. Okay, so now RS, so what do? We subtract R from S. So what is my S? My S is 7, 4. So 7 and 4, and what is my R? My R is this is actually 3, 7. Okay, R is 3 and 7. 3 and 7. So what do you get here? You get 4 and -3, right? So clearly QP vector is equal to RS, right? So this means PQRS is a parallelogram. Okay, so that completes this paper. Students, please like, share and subscribe. We'll come back again to do another set of questions.